Hey, before we get started, I'd just like to thank this conference's sponsors, Captain Hyperscaler and Trace3, both consulting companies. Here's their links and some info, so go check them out. All right, how's it going? I'm Daniel Ward. This is Deploying to Azure with C# using Pulumi. This is for Azure Back to School 2024. The QR code on the first slide here will take you to a blog post on my blog with the slides on it. It'll have the GitHub repo on it. And when it's up, it'll have the YouTube link for this on it. So if you want to see the code or any of the links or anything using this presentation, then scan that. It'll be on the last slide as well. And overview for this talk, so you can kind of know the cadence as I'm going through it. I'll go over what Pulumi is and why you might want to use it. If you're not as familiar with infrastructure as code, the concept in general, I'll go over why you might want to use that. We'll look not too deep, just one slide under the covers of how Pulumi works, whether or not it's open source, and some tools that are available for you like Pulumi Cloud and Pulumi CrossGuard. Then we'll get into basically the meat of this presentation, which is the coding demo, and then some additional tooling and resources that you can use. But first, real quick about me. I have been a developer for about 10 years now. The last few years, I've also been a consultant and coach for a company called Lean Techniques. We help companies do digital transformation. So sometimes that means going to the cloud for the first time. Sometimes that means learning TDD and testing. Sometimes it means just doing software better. So it could be a bunch of stuff. I'm a Microsoft MVP in .NET. I'm the co-organizer of the San Antonio slash Austin .NET user group. Before COVID, these were two separate groups, and now we're acting as one. You can find me online at my blog, primarily .NET technical blog, at daninacan.com. At X and Twitter, Daniel Ward Dev, and LinkedIn, also Daniel Ward Dev, just with dashes. So please do hit me up on there, especially if you like this talk, if you felt like you got something out of it, or if you just have feedback. Would love to hear from people who saw this. Okay, so what is Pulumi? This is kind of my own, tried to condense summary here. It is a tool for writing infrastructure as code in a programming language instead of JSON or YAML, like you might be familiar with already. So you just write code, in our case, C# code, and it translates your code into API calls to create resources. So in our case, these will be calls to Azure. Here's all the languages it is available in currently. So pretty good spread. And they even say that if there's something you want to see not on this list, then let us know. And just to kind of give you an idea of what we'll be looking at, here's an example of real simple, valid Pulumi program that will create a resource group and a storage account in Azure. So it really is quite simple. You can see we're just creating normal C# objects, right? In the case of the storage account, we're setting some properties on it too. And we're telling it the resource group it should be in using our other resource group object that we created. And Pulumi will look at the objects we're creating and make Azure calls from that. It does everything else for us. So why Pulumi? Why should you use Pulumi over other tools that are out there? Well, I think one of the main benefits is you get the benefits of not only IAC, but also a programming language, namely a programming language that you're familiar with. So you know how to use C# already or whatever. You don't have to learn this new ecosystem. You know how to use your IDE and the IntelliSense. You know, you get the type safety, all the tooling that's out there. You don't have to reinvent the wheel because C#'s been around for forever, right? And there's a lot of libraries out there already that you can just throw in a Pulumi program because it's a normal C# program. And the other benefit is that it's cross-language. So if your company, if all the teams aren't on the same language, which is common, that's okay. They can still share Pulumi knowledge because the Pulumi concepts are all the same, right? So they can still help each other out in that way. And in general, not just Pulumi, why should I even be using this infrastructure as code thing? Well, I think there's two primary benefits here. One is the dev teams. So dev teams can move a lot faster when they are responsible for managing their own infrastructure. They can do a lot more for the company and experiment more, get their stuff out faster, because they don't have to send in these tickets, these requests to have, can you put our app on the server? Can you beef up the server with more CPU stuff? Can you create a service bus? Things like this that they just have to wait on maybe for a few days. And they do have to figure out how to configure it correctly, but it's one and done, right? Because when you write an infrastructure as code, that's stored in source control, so you can do it again repeatedly. And the other benefit is the operations team, sometimes called the platform team after you make these changes. But because the dev teams are managing their own infrastructure now, the operations team don't have to deal with those tickets anymore either, which are super repetitive. Just kind of like, it's not very creative work, right? It's like I said, maybe copying files to a server, maybe making it a bit beefier. But it's really not very interesting work, right? So their role kind of shifts to be more org-wide. So they look for problems that affect a lot of teams or all teams in the org. So as an example, like logging solutions. Every team in your org, it doesn't matter what app they're making, they're going to need logging. So rather than every team have to stand up an instance of Splunk or Dynatrace or something else you use, a platform team can set this up for the company. They manage it themselves. And then they just tell teams, here's an easy way for you to hook into this, right? So that's an example, but it's not just that. It's any problems you see that lots of teams are recreating and solving themselves that you can save the company money with. Okay, now final thing for these infrastructure concepts is this idea called cattle, not pets. This was supposedly turned by Bill Baker. You can read up on it here if you'd like to kind of see a history of that. The idea is you should treat your infrastructure like cattle, not pets. So a pet is irreplaceable and cute, right? You name your pets. You definitely manage them yourself, individually, manually managed. And really, they should be more like, your infrastructure should be treated more like cattle, where, it's replaceable and just okay. You're not trying to get rid of your infrastructure, right? You're not trying to replace it. But it should be no problem at all to replace it, right? And because you're probably going through them consistently, you don't give them names. They don't stick around forever, right? They are numbered, they are identified in some way so that you can refer to specific ones, but they're rotated out regularly. So there's no point in like getting attached and naming them, right? Whereas with a pet, if a server goes down if it's red alert when a server goes down, you probably have pets, right? Because with cattle, it should be automated management. So that means automatic disaster recovery as well. So a good, in my opinion, benchmark for this, an ultimate goal should be you should feel completely comfortable just deleting the resources for your app and then standing them back up again without losing anything. Either standing them back up manually or having that done automatically as part of your disaster recovery. And if you've heard of chaos engineering, which some companies actually do in production, it's this concept of they have a service that goes out into their production accounts and just deletes resources to make sure that they are stood up again automatically without the team having to do any manual intervention. So it's kind of like constant real-time testing of their disaster recovery services. So this is an ultimate goal. It may not be, if you're learning this stuff for the first time especially, it may not be what you start out with, but this is the idea you should have in your head, right? Okay, like I said, just a single slide, won't go real deep on this, but I think it's good to sort of know how the tool you're using works under the covers. So how Pulumi works. There's three parts really. There's the SDK, that's just a normal SDK. It's the code you write in C# or whatever. The CLI, how you interact with Pulumi, will run Pulumi up, things like that. and then the deployment engine for Pulumi, which is how your resources actually get out into your the cloud provider. So these two diagrams I'm going to show are just straight from the Pulumi docs, but I'll just sort of explain them a bit. So the first one here is sort of how your Pulumi project is structured. So you can see the big outer box is your whole project, and they say a project has multiple stacks over there on the right, the 3 stacks. And stacks are individual configurations of your project. So the examples here are dev, QA, and prod, right? So it's kind of the same concept as a Git repository and the deployments there. You have dev, QA, and prod. It's the same project, right? It's not a different repo, but it's different deployments of that repo. So it's the same thing in Pulumi. You have the same project, but the different stacks, probably deploy to a different cloud account. You might change some of the configuration. You might change some of the variables. You probably don't have disaster recovery if it's not prod, for instance. And then in your Pulumi program over there on the left, you're creating resources and code that pass their inputs to each other and have outputs to create the other resources, things like that. Now on this diagram on the right, this is sort of how Pulumi works with the different parts of Pulumi to finally get your resources out into the cloud. So it starts in the bottom left here. You can see their example is in JavaScript because it says index.js, but that doesn't really matter. It starts with the language host. So when you run Pulumi up, Pulumi has its language host that starts the runtime for your language. So in our case, that's .NET. The blue arrow here is you've written code, right? That creates resources, that creates C# objects. So the CLI sees that, and it sends that information to the deployment engine and says, hey, in real time. And it doesn't run through the whole program and send that. It goes line by line. So you create a resource group and a storage account, right? So that sends that information to the deployment engine. It doesn't mean those things are created immediately. It just means the request for that state has been sent. And as you can see here, it looks at the last deployed state up there on the top. It looks like a database. So the way it knows what to deploy is it looks at the current state you are requesting, and it compares that to the last deployed state. And these states are just JSON files. You can look at them if you want. And the CRUD operation will be based on that. So for instance, if this resource group exists already, then it won't do anything. It won't create it. If it exists already, but you're changing a property on it, then it'll do an update, right? If it doesn't exist, it'll create it. And if it did exist before, but now it doesn't in the new state, then it'll delete it, right? And these calls to the cloud provider over here on the right are these are called resource providers in Pulumi. So the ones here are AWS, Azure, and Kubernetes. Kind of the cool part to this, which I won't go into because I feel like it's kind of an advanced topic, but you can write your own resource providers if they don't have something that fits your use case. So I think the example they give in their docs is maybe you want to write a provider for WordPress or something, right? Depends on what you're doing. I want to say probably you won't have to do that, but it's cool that it's possible. And there are 2 parts to the resource providers. One is the plugin. This is the binary that actually interacts with the cloud provider, like Azure or AWS. And then there's the SDK, which is the C# code that you're writing. Those are both part of the resource provider. Okay, so Pulumi, is it an open source tool? So the CLI and the plugins that I just mentioned, those are both completely open source. They're open source under Apache 2.0. The part about the state, comparing the JSON files, that's called the backend. So the default is Pulumi Cloud. That is free for individual use, but it's paid otherwise. That is not open source. That's proprietary and, like I said, paid. And it's not just the backend. There's a bunch of other services in there. That's Pulumi's SaaS offering. That's their that's what they market, right? but you are in no way locked into Pulumi Cloud. You can self-manage that state, that JSON stuff if you want. You'll have to take care of auditing and security yourself if you want any of that, and devs to do that. But you don't have to use Pulumi Cloud. It's completely optional. And you can self-host Pulumi Cloud. I thought that was kind of interesting. So that's not free either, but it's an option. So I think the way they word it is Pulumi is open source with a SaaS offering. So I guess that's another way to look at it. We'll see this in the coding demo, but this is just a screenshot of the Pulumi Cloud website, which, by the way, you will need an account to try this stuff because it's the default option. Pulumi CrossGuard is an offering from Pulumi that's free. It's a tool for what's called policy as code. So that's logic in your infrastructure to enforce across your whole company. So for instance, you might say, well, we'll see an example in the next slide that says you are not allowed to use any IoT services. So if a team writes Pulumi code and that ends up trying to create any IoT service, it kicks them out. It does not let them deploy it. And you actually have an option there. You can either report those violations or remediate them. So a report can either just notify the team about it, but still let them do it, or it can just stop them completely. It depends on what level you use. Or you can remediate it, which means you're actually changing their state to be correct according to the policy, and then deploying that. That sounds a little iffy to me because, you know, maybe the team didn't realize that it was remediated. They thought their stuff was deployed, and then what's actually out in their account doesn't match up with what's in their repo. But you can make your own decision on that. These two links here are just some useful pre-written examples of a bunch of policies that you can either just use, or it's a starting point to use. You can see that second link there says policy packs. A policy pack is just a collection of related policies that you can run together. So these are out there available for you to use or build off of. Important to note, because these are also not JSON or YAML, they're written in code, but currently you can only write them in TypeScript and Python. Now, at the time of this talk, it seems like there's a GitHub issue right here that I'm linking. It seems like C# support for writing these is coming like extremely soon. So like the update for this was like a week ago or something. So hopefully by the time you see this talk, that will already be out there. I won't go through this whole thing, but this is just an example of some policies. See the top, they're making a policy pack for Azure. This first one here, you can see it says associating public IP addresses is discouraged, and the enforcement level is just advisory. So that's the lowest level one. It won't stop them from doing it, but it'll just notify them of what they're doing. And you can see it's saying validate resource of type network interface. So it's anytime they create a network interface object. And it says if there are IP configurations.sum, if there's any public IP address IDs, then they call this built-in report violation function. Whenever that's called, that means you failed the policy. As an example of a mandatory one, there's the bottom one, the example I gave. It says use of IoT services is prohibited. This is mandatory, so it will kick you out if you fail it. And the way they're validating this, they're just saying if the type starts with Azure IoT, we won't let you do it. And that's something Pulumi names it, so it can't be changed. Okay, now let's get to the good stuff, the coding demo. You can see I've listed some requirements here, which I will not be going through because I only have so much time for this, and it's just kind of easy stuff, to be honest, that I felt like was not worth showing. So like installing Pulumi, I'm not going to show. Doing an AZ login, I'm not going to show. But you need a Pulumi Cloud account, you need an Azure account, and you need to be logged into Azure on your CLI. Okay, so that stuff I'm not going to show. I'm going to start from making a new Pulumi project. So all the installing and stuff, I'm just going to skip. I think that stuff is pretty easy to follow on their docs. Their docs are quite good, in my opinion. Okay, so let's get to it. So I have an empty solution in my IDE here, as you can see. I'm starting with the solution because the Pulumi, when you create a Pulumi project, it just creates a CS proj for you. It doesn't create the solution. So I want them to be in a solution. So that's what I'm going to do. And the way we do that is Pulumi has a bunch of templates that you can start from. So I'm going to start with a real simple one. I'm going to say Pulumi new Azure C#. And I need to make a directory for that project first. So I'll just say Azure BTS 2024 .infrastructure. I want my infrastructure to be its own project separate from my app. Then I will feed into it and then run my command here, which is Pulumi new Azure C#. And it will ask me a few questions, like what do you want to name your stack, things like that. When your project, I'm going to accept defaults for all these. West US 2 is fine. Okay, it's telling me there's a new version of Pulumi available, but that's fine. Okay, so it says your new project is ready to perform an initial deployment, run Pulumi up, which we will do in a moment. So I'm going to add that project to the solution. Existing project. It is. All right, so you can see, maybe help if I zoomed in IDE a little. Yeah, that looks pretty good. Okay. Did not keep. There we go. Okay, so you can see it didn't make much of a project here, which is nice. Be easy to go through. One's a git ignore. Not much to say about this. It's a git ignore file. Two YAML config files. This one is the config for the project. You can see here's some of the default values I accepted in the prompts it was giving me in the CLI. And this is the config file for the stack, for the dev stack. And for this, there's only one value in here, which is the location we're deploying to. Right. Okay. Now, program CS, here's our Pulumi program. And it's kind of, this is that code snippet here I showed you earlier. So there's a little bit of additional stuff in here. So let's go over all this. As you can see, to create resources in Pulumi, we really it's just newing up C# objects that they provide for us. And you can see it's in this format of, we give it an ID, which is a string, then it'll be the args for whatever that type is. In this case, it's storage account args. And here we set all the Azure, all the options it has in Azure. So there's a bunch of other stuff on here. We don't have to set it, but it's there if we want to. Okay. So, and here, I think we're just going to start with the Pulumi up. But here we're actually invoking a call to Azure in our program. It says, hey, list my storage account keys. And then I'll explain what this does in a moment, but where this just says, hey, the keys you get back from that API call, just take the first one because that's the primary key and obfuscate it, make it a secret. We're going to save that as primary storage key. And then we're returning a dictionary of key value pairs here, right? And we're putting that storage key in the dictionary. So let's Pulumi up. Let's see what happens with that. And I need to go into my infrastructure project. And Pulumi up for update. And right now it's running my program, but it's doing it as a preview. So it can tell me, here's the things that I'm going to do. Are you okay with this? So as we expected, everything's new, right? So here's my stack. Everything is inside of that one stack, which is a resource group and a storage account. And here is the output, which is a primary storage key, right? That's what I called it. But I didn't see it, and that's because it's a secret. It didn't actually output the value. So do you want to perform this update? I can say yes, no, or details. If I say details, just gives me a bunch more information about it. Probably a bunch of stuff I don't care about, but the option is there. So let's just say yes. I do want to deploy it. And by the way, on this output, if you do want to see secrets, that is possible. I will show you in a moment after this is done deploying. It seems like it takes longer on the very first deploy. In my experience, it usually takes around 30 seconds for this first deploy in this template. But these outputs are useful if you want to pass it to something else in the CLI, another program, if you want to do something with it. So there it is, 3 created, 32 seconds, and outputs primary storage key secret. Okay, so this was just because it was the preview to correct myself. Here is where we can't see it, where it says secret. So if I did, you can look at your stack outputs. If you do Pulumi stack output, so you can just do that, or you can give it, if you only want to see one output, you can give it a specific name and only print that one. But again, it's a secret, so we can't see the value, right? So to get around that, we can say show secrets. There it is. So this is nice because we probably don't want to be outputting our secrets in our CLI when things happen, but maybe you do need to feed that into another program, or you want to put into a file or something. And something else that's kind of useful is I will do JSON. Let's get rid of the show secrets. I guess it's just because it's because I'm doing primary storage key. So I'm saying, hey, print all of my outputs as JSON format. So it just formatted them as JSON, which is useful. Again, if you're feeding them into something else, if you want to put them into a file or something, a lot of times it's easier to parse JSON depending on what you're feeding it into. So that can just be a nice tool. Okay, so let's go and look at Azure now. See if our stuff got created. And let's go to resource groups. And there it is. There's our resource group. There's one resource group. So let's look at him. And he does indeed have a storage account in West US 2. Now, you might notice this is not what we named our resources, right? We named it, as an example, we named our resource group, but it didn't name that, did it? It named it resource group and then this hash thing. And same thing with the storage account here. So what's the deal with that? Well, that is intentional, and it's recommended you don't change that behavior. So the reason that happens is to ensure unique names, so you don't run into name collisions. So sometimes when Pulumi has to perform an update, the cloud provider requires, for whatever reason, that it can't update in that way. It has to delete that resource and recreate it with the new values. So when that happens, the way Pulumi does that, it first creates the new resource and then it deletes the old one. Okay, and it does that so you'll have 0 downtime. If you deleted the old one first, you'd have a small amount of downtime in your app. So that's the reason they do it. But if you are using a static name that's constant, like resource group, when it creates that new one, before it has deleted the old one, you'll run into name conflicts and it will be unable to create it. So by using this, little unique hash, it ensures that won't happen. Also, if there's another team, or if just the same team with multiple apps in this account, let's say, this would be totally understandable, but you're just being a little careless. You named it resource group in both of the Pulumi apps. Well, that's another name conflict, right? There's already something named resource group in this account. So again, adding that uniqueness to it keeps that from happening. Okay. Now, we are going to look at, you know what, let's create another stack. So we talked about stacks. Right now we just have one stack, right? So creating another stack is quite easy, but I will need another file. Let's open this up in Explorer. I'm just going to copy paste it, and I'll rename it .prod.yaml. Okay. And we'll just keep this the same. And then we'll say Pulumi stack init prod. So you can see create a stack prod. Now, even when you have multiple stacks in your project, the CLI only works with one at a time. Okay, so there's a concept of like the current stack that you're working with in the CLI. So you can say Pulumi stack select, and then the name of the stack, which is prod. So whenever you're running commands, you can also specify the stack with like Pulumi. So I could still get the output of the dev stack by saying output s dev, and that tells me, you know, use the dev stack. So that's just a good to know. And I want to show you, if I go to, this is Pulumi Cloud, and I'll refresh here. You can see here's my app with 2 stacks in it. So you can see this stuff in the web UI too, if you like that. And the dev has a check mark next to it because, you know, I had a successful deployment 7 minutes ago. Prod, nothing's happened with it yet. It's there, but nothing has happened. So I just wanted to show you that stack does exist in my Pulumi project because I created it in the CLI. I just haven't deployed it yet. Okay, so Pulumi is separate from your cloud provider. Those are 2 separate states. Now, if I did Pulumi up again, it's going to create all those resources again. Say yes. Now, in real life, I only have one Azure account. In real life, this would probably go to another Azure account or something, right? But just to showcase how kind of stacks work. Cool. Now, let's just go and make sure we should have 2 resource groups now. So there we go. I don't remember which one of these was the first anymore, but they should both have a storage account in them as well, right? So there's one, and there's the other one. Cool. So that worked. And again, the whole cattle not pets thing, you should be okay deleting your stuff, right? So I'm going to show you how to do that. So there's 2 concepts when deleting your stack. There is Pulumi Pulumi destroy. And this will destroy your current stack. So destroy does not delete the stack. It deletes the resources in the stack. But the stack will be in your Pulumi account still to redeploy later. Okay? So that's a very important distinction. So it's saying here, here's the diff. I'm deleting these 3 resources. This might be cool to see too. It gives you a link to the Pulumi cloud page in your account if you want to see this deployment. So you can see it in the cloud as well if you like that kind of stuff. And I'll say yes. My experience deleting the whole stack usually takes a little bit longer than individual new resources being created as well. And we will just be ready to look at our new states once that happens. So it's done. It looks like it might have already updated. Let's refresh to make sure. Yep, there's only one resource group with a storage container in it. So that worked. Now, you can also remove the stack, as you can see here. So let's do that. Pulumi stack rm prod. Now it's going to be like, oh, are you sure you want to do this? Because this is going to remove it from your account. So let's go to here again. Now let's type prod to remove it. It's been removed. Now let's refresh here. And as you can see, it's gone. It's gone from our account. So that's the bigger deal one, right? Now, we're not going to do anything with this, but I would like to point out, you can, that state I was talking about that in the slides, the JSON file, you can view that if you like. You can do that with Pulumi stack export stack.json, whatever you want in the file. Oh, no stack selected because I deleted my prod stack. Pulumi stack select that. And then export the state. So here it is. So again, we won't be managing this directly, but kind of cool to see what's going on under the covers. Here is the state JSON that Pulumi compares against. So, you know, here's what my name is in the Pulumi cloud. Here's the resources I'm creating. Here's a stack. It'll have resource group in here somewhere. Here it is. So, you know, it's got quite a bit of information here. My project's quite small, and it's still almost 200 lines. So, again, we won't be using this, but cool to see. This is what you'll be managing yourself if you use your own backend. Okay, now let's look at an important concept here. Let's manually delete something in here. Let's first of all, let's just say we want to add some tags to this guy. Doesn't matter what they are. To the storage account. Whoops. But then we're going to go into Azure and manually delete that storage account first. Delete him. And just wait until we know for sure he's finished. Okay, so he's gone now. The storage account is deleted, right? But we're updating a value in the Pulumi stack, right? So let's see what happens when we run Pulumi up, and what do you think will happen? The account has been deleted from Azure, but we're trying to update this resource in our Pulumi stack. Okay, so let's see what happens. So as you can see, it said there was a diff, but we got an error. And in this case, it's actually because of this list storage account API call we're doing. And it's saying, hey, service returned an error, resource not found. The storage account under resource group was not found, right? Because we deleted it. So I want to note a couple things here. And this is an important concept in Pulumi. Pulumi does not keep track of your cloud provider's state. Doesn't know about it. Pulumi keeps track of that JSON file I showed you. It knows about Pulumi's last deployed state, and it will deploy according to that. Okay? So because this storage account was not deleted in my Pulumi stack, it didn't think it needed to be recreated. Right? It thought it needed to be updated, which is what we saw because I changed tags on it, right? So that was an update. That's what you see here. So it just registered this as an update, but then when we tried to call the list storage account keys API call, Azure said, that storage account doesn't exist. So this is called drift because the state of your actual cloud provider has drifted away from the state of Pulumi. And the easiest way to avoid this is just not manually manage stuff in your cloud account. Maybe for one-offs, for testing stuff to make sure you've configured something right. But in general, if you're using Pulumi to manage your cloud resources, you should only be using Pulumi. Manage everything through Pulumi. Drift can be quite annoying to fix. Now, I will say there's a caveat. I think maybe this is Azure specific. What I just described is what they say in their docs. But I have had cases where Pulumi registers for instance, maybe if I didn't have this API call in here, Pulumi registers it as an update, but then when I go back into Azure, it has actually recreated the resource, which doesn't make sense to me. And it does not appear to be what their docs say. So I would not count on that behavior. I don't know if it's a bug in the Azure API, a bug in the Azure plugin for Pulumi. Could be I'm not understanding something. I will take correction there if that's the case. But I would not count on that. The concept to take home from this is Pulumi does not keep track of the state in your cloud provider. Okay. However, if drift happens, Pulumi does provide something to help fix that, which is just Pulumi refresh. Or when you run Pulumi up, you can do -R, and it'll do a refresh first. So Pulumi refresh will actually reach out to your cloud provider and see if there are any differences. Okay, so let's run that. And it says, oh, this doesn't exist in your cloud provider. We need to delete it from Pulumi's state, right? We need to delete it in your stack because that still exists in your stack. It says, do you want to perform this refresh? So I'll say yes, refresh it, which will fix my Pulumi state to match the Azure state. Okay, and now I can run Pulumi up again, and you'll see now it knows I need to recreate this storage account. And it'll go through that again. Now, I think refresh most of the time is probably going to be fine. But there is another method, maybe more fine-grained, to fix this, which I will show as soon as this finishes running. Okay, so it said it's finished. Let's just make sure of that. Probably need to go back into my resource group. There, so there's my storage account. Cool. Okay, so the other way you can do that is you say Pulumi stack. Let's say you need to delete something in your stack. You can say show URNs, which is universal resource name. So here is the stuff in your Pulumi stack. If you needed, if something was deleted in Azure but was not deleted in your stack, you could just copy one of these URNs. So if I wanted to delete the storage account in my stack, I'm not actually going to run it because it's working correctly now, but I would copy that URN and then say Pulumi state delete, and then just paste the URN. Okay. And actually, let's go ahead and do it. So this will edit your stack state directly. You want this, yes. And I guess to make it work, I will delete the storage account just so you can see an example of this working in action. So this will be, once all this is finished, it will be deleted in my stack and in my Azure account. So now it's deleted. While we're waiting on it to delete in Azure, good concept to be aware of, this unique resource name. Remember how I said Pulumi adds that hash onto your resource names in your cloud provider? Well, there's two names to keep track of. And the two names here are the logical name, which is what you named the resource in your code. And then there's the resource name, which is what Pulumi has named the resource in the cloud provider. Now URN, I think I said this was a unique resource name. It's uniform resource name, but it's just internally Pulumi has this name to refer to this resource as a globally unique identifier. So you won't have to mess with this. But that's how Pulumi uses it. Okay, so I think we can look at something a little more interesting now. A second template. And actually, let's go through the concepts real quick of inputs and outputs in this template. because you can see them being used here briefly. So when you create a cloud resource, a bunch of stuff is initialized in Azure, like the name, a bunch of other things that we didn't specify maybe in Pulumi, but Azure still fills out, or maybe some things that we filled out, but Pulumi changes, tweaks behind the scenes, like the name, right? So the point to take home from that is that there are values, most of the values on the resource, that we cannot know until the value is actually until the resource is actually created in the cloud provider, right? It is impossible to know those things at build time. So how does it work when we pass something like, we say the resource group name used for the storage account is this guy, when we don't even know this value at build time, right? We only know it when Pulumi is actually starting to deploy our stuff. And this is the concepts of inputs and outputs in Pulumi. So that's where outputs come in. An output you can kind of think of like a task or a promise, if you're familiar with these concepts, but it's the same concept of deferred execution. And you can see this resource group.name is not just a string, it's an output of type string, okay? And the resource group name on the storage account that we're assigning is an input of type string. So what is an output? So we had a resource group, it was created, and then it has a bunch of outputs on it that we can hook into, right? So an output is just that. It says, you can refer to this value in code, but it will not be known until later, okay? So defer execution of this until the resource group is actually created, right? So these outputs and inputs help Pulumi build up this dependency tree of how the resources depend on each other, right? So now Pulumi knows I can't create this storage account until I create this resource group first, okay? So the way an input works is you can assign an output to an input, but you can also assign just the T, okay? Because if, let's say, the resource group name for some reason is known at build time, that's fine, that'll work, right? An input can be a static value, that's just fine. But it can also be something that's not known until deployment time because it's coming from another resource, right? So an input can be basically either assigned an output or the actual thing, okay? So it's just a little more flexible. I don't know why it's showing me the docs. There we go. Okay. So this is important for this method here, apply. What is apply? So apply is doing something on an output. Let's say we want to perform some kind of operation on a value that isn't known yet, okay? So Pulumi offers a few methods for this. One of them is apply. So in this case, it's on this Azure API call, which is not made until we're actually deploying, right? Until Pulumi is actually running our program. It's saying, hey, when you make this API call, the value you get back, do this stuff with. In this case, we're creating a secret from the first value in the array. But this is an example. So let's create another template, and we'll see some more examples of this. I would say if this doesn't click right away, that's perfectly fine. This, in my opinion, maybe the hardest thing that was hard. That was the thing that was hardest to wrap my head around in Pulumi. Okay, let's create another template here. Let's just create another project for this. It's called infrastructure 2. And cd into that. And let's do a Pulumi new serverless Azure C#. There are a bunch of templates, by the way, that are useful as starting points. Either as starting points, or if you're just trying to see how to set up a certain type of resource, be useful. Again, I'm just going to choose these default values for everything. And this template isn't setting up a ton of stuff, but it's a little more involved. It's setting up a static website using a function. Let's close this guy out. Add that new project to our solution. Add our existing project to our solution. Okay. So we can see it's created this www folder here. We have the same files aside from that, though. Now, they don't include it as part of the project. If I go into it here, there is an app folder as well with another CS project. And this file is just an Azure function. So I open with writer. It's just a simple Azure function that has an HTTP trigger and returns the daytime now. So that's what it uses for its function here. Now, first thing we see, it's kind of interesting here, is we use stuff from the config. Because we have some more stuff in our config now. We have some paths, right, and some file names. So this is also a good example to see how the config works. Now, it would be nice if you could, normally when you have like an app settings JSON, you can have a one-liner to bind the entire thing to a class. As far as I've seen, that's not available with this. Maybe partially because some of the secret obfuscation and some of the other helper methods it does, not sure. But regardless, here's how it's getting those values. It's saying get site path. Now, it's saying if this doesn't exist and comes back null, give it this default value. There is another option here called require, and this will actually throw an exception if the config value doesn't exist. So it's just whatever you want to use. And obviously, you can just add your own stuff in here, typing. There is also a CLI option for that, though, which is Pulumi config set, doesn't matter, function name, cool function. Yeah, let's just do that. And I added it. I forgot to switch directories, so I added it to my my first project here. But you can see it just adds it for you. What is a little more interesting, perhaps, let's go to our new project, is if I say the same thing, but I say secret, then you can see it has obfuscated that value. And you can still use this value in your code if you do things like get secret or require secret. So we're not going to use that. That's just something that's good to know. And this will not even be able to be read by other stacks. Okay. So let's just go, we won't go over in detail, just in general, what this template is doing. It's creating a resource group in the storage account again. You can see here's the static website it's creating. Then it's creating all the stuff to make a function work with a static website. So synced folder, a blob folder, a blob container. This is kind of interesting. We'll go over this in a moment. It's publishing the actual app, putting that archive in a blob, telling it to, this is just giving the function itself access to the code, create an app service plan, and then we create the function, and we create a blob that is a JSON configuration file, and then we export the site URL and the API URL. So it seems like maybe a lot if you're glancing at this the first time. But really, this is kind of the stuff you need behind the scenes in Azure to make it work anyway, right? We are just putting that in source control. I also want to point out, even though objects like this, we're not using this anywhere. And your IDE will probably even warn you, hey, you're not using this. That doesn't matter in Pulumi. All that matters in Pulumi is that we're newing up this object, right? And it will create it, so whether or not it's used. Okay. Now, let's, first of all, let's just go ahead and Pulumi up this guy. Okay, so it's done previewing. It's telling me I'm going to create all this stuff. You can see now we have some more stuff in our tree. It's saying there's going to be 2 blobs in this blob folder. So do you want to perform this update? Yes, I do. That sounds cool. All right, so it's finished creating our stuff. Took a little over a minute for the first time creation of everything. Here's my old stack that doesn't exist anymore. Refresh this. Here's our new project and stack in Pulumi. Something kind of cool, I don't think I showed before, is just, here's all you can see all the info about it in the web interface as well. Pulumi itself has some tags. Here's the configuration. Here's the outputs. Just a bunch of other stuff. So, kind of neat. And also, if I go to resources, here's all the stuff. And it's kind of cool if I go to graph view, here's here's a graph of everything with the dependencies, right? So the blob folder has these blobs in it. Everything is inside the stack, obviously. Yeah. So again, it's not necessary, right? But it might be helpful if your project gets quite big. So, okay. So let's go to Azure. Let's go back to home. Should have another resource group here now. Our new one is called resource group with a dash. So it's that one. And you can see here's our here's the resources we have in it. Service plan, function app, storage account with stuff in it. Probably the easiest thing to do would be to use the output it gave us. Let's go to the site URL. Just go to that. Oops. And when we click this button, it will trigger our function, which all it does is, that took a moment. All it does is, like we saw, it gets the current time. So just to show you the page we're looking at, obviously it's pretty simple as well. This is the whole thing. So on click, get the time. And this is the whole thing, right? So here's what we call that function. Cool. So this all worked. We created a static website backed by a function. I think there are some things we can make a little cleaner in this, and some things to talk about. So let's look at the function itself, this web app type. We give it a bunch of app settings, right, to make it, for instance, run from this zip archive. Well, first of all, how did we get that zip archive? We have a CS proj, right, in that app folder, but we have to publish that and then get the artifacts, zip that up, we have to run .NET publish and put that in the blob. So that was this run.invoke that Pulumi provides for us. This is quite useful. We can run arbitrary commands at the time Pulumi is running. So in this case, app path was just /app where our app was located. And we can publish that. We can run .NET publish on that location, put it in a folder named publish. And then what we're doing, here's that apply command again. So we're saying the result of this command, you will not run until stuff starts being deployed. Take that and make a file archive out of it. Basically make an archive, put it in a blob. This is a fancy way for doing that. So we put that value to be run in this to be used for this app setting, this website run from package. So this output.tuple, this output class, right? This says this little this function here that you're running is dependent on all these 4 values being defined. These have all come back from Azure in one way or another, from Pulumi creating resources. Okay, so output.tuple says these 4 values, basically everything you put in here, shove it into an object, shove it into a tuple object, and then you can use it. There's also a .all, which is similar. It just says shove everything into an array instead. And I'll show you a cleaner way to do this in a moment, in my opinion. But it just gives these tuple values a little bit of a cleaner name, and then it returns an interpolated string from them. And that's what it uses. This is the blob URL, right? And that's what it uses for the website run from package. Now, these 2 lines are equivalent. And I think this is what they should use instead, really. There is another method on output called format, which lets you use this pretty much like a normal string format. So if I say count.name, actually let's just copy paste this and then work from there. If I say account.name, app container name, app blob name, and signature. So I'll comment it out so I'll stop getting complaints. But these 2 things will result in the same value. So I think output.format is always cleaner. I don't know why you wouldn't use it. But output.format says, why it's giving me docs every time I click. There we go. Says, I will create this interpolated string for you only when I have all these values back from Azure created resources. So it knows it's dependent on all these values, right? Okay. Cool. Now, let's say we did this a lot. We created a lot of functions. Well, this is kind of a lot of code, right? Not all of it is for just the function, like resource group and storage account. We'd probably need those things no matter what, but a lot of this stuff is just to have a function. It's kind of a lot, right? Well, this is where a very useful concept in Pulumi, maybe one of the most fun things, is component resources. So there's 2 kinds of resources in Pulumi. There's custom resources, which it's kind of backwards to be honest. The custom resources are the things Pulumi provides for you, like blob, web app. These are custom resources. Component resources are ones that you can create, which are just, you can put anything you want in a component resource. And it makes it easier to repeatedly create things like this, number 1. And it allows you to have this idea of sensible defaults. So I'll just show you. I have an already created project in here, 2 projects actually. And this is, I just took this template and I did 2 things. One is I cleaned it up a little bit and put it inside a component resource I called static website function. And 2, I said, you know what? I want to have logs in my function as well. There's no app insights in this template. So I'm going to add app insights to it. And I put that inside this component resource. So ignore this for a moment. These are the input arguments, but you can see my static website function is inheriting from component resource. We have to call this base constructor here. So same thing, we give it a name. We give it args like every other resource we create, right? And that's a custom class that just has to inherit from resource args. We'll look at this in a moment. It takes some options, which default to null. We'll look at that as well. And then you call the base constructor. So this ID here, they recommend you do this format here, package : module : type. Now .NET doesn't exactly have those same terminologies. You can see here what I've done is my org name in Pulumi, which is Daniel Ward Dev, and then kind of, I guess in this case, maybe it would be Azure BTS 2024, and then like static website function, perhaps. Maybe that's a more fitting name. And then inside of it, for the most part, if you remember, this is pretty much the same thing the template was doing. I just brought it over here. Okay. Now the one difference, like I said, is I'm also adding App Insights to it. So we take an App Insights instrumentation key as part of the input arguments, because there's a possibility you might have the same App Insights for multiple things. I don't want to create a new App Insights every time I create a function. So instead, I say, hey, pass in that instrumentation key. So let's go over these inputs. So again, remember we talked about inputs. They can take an output, or they can take, in this case, string itself. A lot of these are similar to the things we've already looked at. We're taking a resource group name in to know what resource group to put it in. Same thing with storage account name. Everything else is just stuff we need to create all the resources in here. Now, maybe the more interesting one here is net framework version. It's defaulting to 6.0 if they don't pass it in. So here we go. So he's used here when we create the web app. Now, you might imagine you don't always want a 6.0. So you can pass in, because 6.0 is about to fall out of support, I believe. So we decided we would let them pass that in. Now, also, we are saying our app service plan is on Y1 named tier dynamic. This means it's on consumption plan. That's how that's defined. But maybe we don't want consumption plan. We want something more powerful. So you could imagine maybe you make an enum or a string as one of the inputs that says what kind of plan you want it to be on. And from that one value, you can set things in multiple resources. So it's less setup, but you can still be sort of flexible. And by doing stuff like this, you can enforce this idea of sensible defaults. So rather than in my stack setting all this stuff every time, I'm probably okay if it's consumption plan every time, for instance. But maybe in some cases I want to override that. So you can expose things through the inputs that allow overrides, but if they don't pass those things in, that's okay. There's still a default value. That's probably okay for 90% of the cases. So in this way, you can make these shareable component resources, depending on how general you make them, shareable across the org, across teams, right? Saying, hey, we made this component resource for a general use static website function. So you can use this. That's, as you can see, like 150 lines long. So you don't have to write this every time, okay? Now, this register outputs you see at the end here, this is actually not required to be called. I kind of looked into this a little bit, and there's actually a GitHub discussion on like, hey, it says to call this in the docs, but it doesn't say why. Why do we need to do this? And some Pulumi employees even replied like, we're not actually sure either. And it was like several years long discussion, but essentially it seemed like they said, you don't have to call it, but it's best practice to, because it lets the CLI update the progress bar. The CLI will know this component is done when this is called. And you can pass outputs in here as well. But this is another question, which again is just a dictionary of key value pairs. But this was just another question on the thread that was like, I don't think we need to do this because we can just expose things as public properties. Here I'm exposing the web app in case maybe the caller wants to hook into that somehow, look at something on it. And there doesn't seem to be any advantage to using the outputs here. So I'll link that GitHub discussion, but it seems like, as far as we can tell, it's a one-liner to call it to update the CLI. So sure, is it going to kill your program if you don't do it? No. Does it seem like you have to actually put outputs in here? No. Now, you might have also seen I'm doing parent equals this everywhere. So to look at that, let's let's run a Pulumi up in this real quick. Up in here. Say Pulumi up. But essentially, this is kind of annoying, to be honest. You have to do this just like on everything in the component resource to let it know, to let Pulumi know what the parent is in that stack. And I do not have a dev stack in here, actually. Pulumi, you know what? I'm just going to copy these values over. You know what? Yeah, let's do it. I don't need those config values, I don't believe, anymore in mine. But this will still probably just be easier. Pulumi dev YAML. It won't hurt anything at the very least. I'll say Pulumi stack init dev. Pulumi up. And this will let Pulumi know all of these are children of this component resource in the stack. So it's kind of annoying, to be honest, but got an error. I forgot to include my other project. So, like I showed you in the original template, the second template I made, our Infrastructure 2 project, they have an app folder with their actual function code in it, right? I don't really like to do that. I like to keep my infrastructure project only infrastructure. My actual business projects are their own projects. So that's what I've done here. I have a .app project, and he is the same function. I just called him getTime function, but you can see he's the same thing. And he now has the error and index pages inside of this project. So I like to separate my concerns that way. So I wanted to show you how you can still make this work across projects. And in my, I don't think I ever showed this being called. So you can see this is quite a bit smaller now, even with the new App Insight stuff we're creating, right? So we're creating a resource group and storage account. We have to create a workspace for App Insights. So that's what I do here. And here's App Insights. And then here's where I make my custom, it's not a custom resource, it's my custom component resource. So here's my component resource. So in like 10 lines, we're doing like 150 lines or so worth of work, right? So that's quite nice. And we see here in the site path, it's going up a directory, then looking at my service.app, and same thing for app path, right? And that'll work just fine. So let's pull me up. So this failed in because when I was testing stuff, this is what my project was named, and it is no longer named that. It's called Azure ETS 2024. Yeah. Perhaps an argument for using reflection here. I believe that should be good. Let's run Pulumi up one more time. Okay, so here we go. I noticed I had not put parent on everything in this component resource, so I did that. And you can see here in the preview, I'll do yes. It's running. I don't know why it says that twice there. And you can see what that's done. And our output here is it's put everything in this component resource as a child of it here. So it's useful to see where everything is coming from. So it's useful. On the other hand, it's a little annoying because you just have to put that on everything in the component resource. So this is a good time to mention that there's really 3 parameters on the constructors for these resources, right? There's the name, the args, which are the Azure configurations, and then there's the options, which are like the Pulumi configurations, right? And usually you don't have to worry about these too much. In this case, we're setting the parent. There's some other stuff on this, right? The one thing you probably do want to know about is this retain on delete option. So I can set that to true, for instance. Anything that has state, that holds state, you will want to consider turning this on for. So a database, maybe a container, um, because if Pulumi ever decides it needs to delete that resource, whether you do stack destroy or you inadvertently delete it by updating the resource and Pulumi says, I got to delete them and recreate them. Well, if that's a database, you just lost all your data, for instance. So setting this retain on delete to true, what happens is when the stack is destroyed, Pulumi will not destroy this resource. Instead, it will orphan it. So that means it will remove it from the stack. Pulumi will no longer associate itself with that resource, but it remains in Azure. So that is good to be aware of. Imagine our deployment is done by now. It took about a minute and a half. And give us our site URL again. So let's go to our new URL here that it gave us. And it's the same app, right? But it's in another project now, right? And that's still working. So we can still keep Pulumi as a separate infrastructure project in our business logic in its own projects, and that still works. And this one's probably a little bit more interesting to look at. Yes. Let's go to dev here. Resources, graph view. So that's kind of cool, right? Here's everything inside of our component resource, right? And then the other stuff that's just in the base stack, app insights, all this stuff. So that's pretty cool. There's one last thing I wanted to mention, and that is how to debug. Like if you want to set breakpoints in your infrastructure projects, because you can't just hit debug from up here. Pulumi's recommendation for this in their docs is to put this in the stack. This. You got to make this async. And while the debugger is not attached, it'll just keep waiting a second and then checking again. So how this works is, let's say I'll put a breakpoint here. I run Pulumi up. So it seems like you wait for this to say completed successfully here, and then it'll be ready. So Pulumi is running my program. It's just stuck in this state because the debugger is not attached, right? So then in your IDE, you say attach to process. You find, here it is, attached with .NET Debugger. So now it'll get unstuck out of this loop. And here it's on my breakpoint. Now, not the most streamlined, but honestly, probably not the most common thing to have to debug your infrastructure projects. But if you need to, here's how you do it. And I think that's about it. I guess we can go see, just for funsies, we can go look at our new resource group. It had a hyphen in it. It did. And this is the right one because it's got app insights in it. So there's everything, right? There's all the resources we created just as requested from Pulumi. So that's the end of the coding demo. The final note, some of the things that will be useful as you are learning and using Pulumi. The templates, like I mentioned, we use 2 of them. There's a lot of templates, not just for Azure and not just for C#. There's a lot of things out there useful to as a starting point to start from, but also useful just to see, if you want to, how the heck do I make a serverless function app? This isn't the project I'm going to use, but this is an example I could look at. Pulumi has some pretty good blog posts that go pretty in depth about like designing philosophy and how to do stuff. Obviously, Azure is not the only tag. That's what this presentation was about. This, I believe, fairly new tool called Pulumi AI is kind of neat. It's a free tool. You just choose your language down here, ask it whatever you want, and it'll show you how to do that in Pulumi. So, for instance, how can I create a function that talks to a database? Pretty general. See what it comes up with. And you can, it's just, I guess, a custom version of GPT that they've made. You can tell it to be balanced, or just do code, or explain. So this is the balanced version as an example. It says, here's a C# code to create an AWS, I didn't specify Azure function, but an AWS Lambda that connects to an RDS. Let's specify Azure just because that's what the my presentation was on, and see how it does that. So it says a function app and a SQL database and the required configurations to allow communication. So as you can see, it spit out some Pulumi code. Here's your SQL server, and here's the actual database. Won't go through everything in here, but it's pretty cool that, you know, even if maybe this is 90% right, I'm not sure, but maybe it's 100% right. But if nothing else, it's an awesome starting point, right? Okay. That's Pulumi AI. Pulumi ESC, I won't really cover. I just want to mention it. It is Pulumi's configuration and secrets manager offering. So the reason you might want that in Pulumi is because you might be going to multiple different cloud providers at a time, and GitHub or something. So all these have their own separate secrets configuration offering. So you might just choose to do all of it in Pulumi if Pulumi is what your company is using. And that's it. So recap, Pulumi, we went through the what, whys, and hows of why to use it, what it is. IAC infrastructure as code in general, why you might want to be using that. How Pulumi works a little bit under the covers we looked at. If it's open source, which we saw yes and no, kind of. The back-end part is Pulumi Cloud by default, but it doesn't have to be, but everything else is open source. Some tools like Pulumi Cloud, we looked at a little bit in the demo, and CrossGuard, which was policy as code. And then the coding demo itself, obviously, which the bulk of the presentation, and a little bit of what we just saw, some toolings and resources. So here's that QR code again to get these slides, repo, YouTube link, and there's where to find me online. Again, please hit me up if you like this. Would love to hear from you. And thanks for watching, listening to my talk.